the lecture. If you want to ask anything, if you have any doubt, and if there is a problem in the voice, if the voice is cracking and all that, then you can just ask me. Okay. So those who are new, for that, uh, I want to just give at least 10 minutes. Okay. So just see here, all of you. Uh, this chapter is the spherical lenses, means refraction we are doing. Refraction of the light we are just studying. Okay. And in the refraction of the light, we have just completed the refractive index, and now I have started the spherical lenses. Okay, all of you, those who are new, please focus here. Okay, and those who have already done this, also I am requesting those focus here. This is your revision. Okay, so spherical lenses are of two types. Okay, convex lens and concave lens. So this type of lens is the convex, and this is concave. Okay, so this is the shape of the convex lens, this is the shape of the concave lens. So now I have defined some of the terms related to the this lens. There are the terms like principal axis, there are the terms like principal axis, optical center. So this is the lens. I have told you this is a convex lens, and this center point of the lens is the or known as the optical center, and the line which is passing from this optical center is the principal axis. And same is the case for this concave lens. Okay, and after that I have discussed what is the focus of the convex lens. So focus, this is the lens, this is the convex lens, and focus is a point where whenever the parallel rays means parallel to the principal axis, okay, are striking on the lens, and after refraction from this lens meet at a point, and this point is known as the focus of the lens. And this distance between the optical center and this focus is known as the focal length. Okay, and talking about the focal length of concave lens, same is the thing. Here the rays are coming parallel to this lens, and these rays are diverging after refraction, and I have just meet these rays in the backward direction, and so this where these rays are just appearing to meet, these rays are just appearing to meet is known as the focus of the concave lens. Okay, and this distance is the distance between the optical center and the focus is the focal length. So this is the definition I have written, and these are some notes, and after that I have discussed there are some rules for the image formation of the convex lens. So this is the convex lens, this is the convex lens. Okay, now focus on this. You know that this is the convex lens, all of you, those who are new. And suppose this is a ray of light, this is a ray of light, and this is parallel to principal axis, and this is optical center. I have already told you optical center is the center of this lens, convex lens. So what will happen whenever a ray of light which is parallel to principal axis, after passing through the lens, it will always pass through the focus. This is the first rule. Second rule is whenever a ray of light will pass from the optical center, it will go straight. It will go straight. Okay. And another case is whenever a ray of light is passing from the f dash. F dash is the second focus. In lens we have two focuses. Okay, two foci in lens. Okay, whenever a ray of light is passing from the focus, and after the refraction from the lens, it will become parallel to the principal axis. So I have used all these things in the image formation of this lens. So this is the convex lens. All of you can see here. This is the convex lens. This is the convex lens. Just wait a minute. This is the convex lens and this is the optical center. This is the first focus. First focus means the distance between the this focus is situated at a distance of a small f. Okay, so I am taking another distance which is again at a small f. Okay, so this O to F distance is f. O to F distance is small f. O to F distance is small f. O F to F distance is small f. Same is the thing you can take on the left hand side of the lens. Okay, so first case I have discussed. This is the convex lens. Suppose you have the convex lens and lens, if you don't know what is lens, so this is the lens. All of you can see. Lens looks like this. Okay. In opticals, we use lenses. Lenses are like this. You can see. Okay. In real life, lenses are like this. So,
Sir, can you excuse me?
yeah. Yeah, Sarah, tell me.
No, like, can I excuse like one for 1 minute? You can continue.
Okay. So, this is the first case I have discussed. First case I have discussed. Suppose you are having a convex lens. Uh, just giving the example. Suppose this is the convex lens. You can just suppose this is a mobile phone, but you have to suppose this is a convex lens. What we will do, we will place the object in front of this lens at different positions, and we will see how the image will be formed. Okay, how the image will be formed. So here I have taken first case when the object is placed between the optical center and the focus. This is the focus of the lens, this is the lens, and this is the focus of the lens. So I have placed this object, this AB is the object. Okay, this is the object. This is the object. This is placed in front of this lens, and I have drawn the ray diagram. Okay, I will explain the ray diagram later when I will discuss for the second case, and we will get the image here. You can see this is the image of this AB object. So you can see this image is larger than the object. And one thing more you have to remember, if the rays are actually meeting at a point, then you will get the real image. If the rays are just appearing to meeting at a point, then you will get a virtual image. Here in actual the rays after refraction is going in this direction. But when I produce these rays in the backward direction, so here at this point these rays are meeting. So here we will get a virtual image. Okay. And this image is beyond the object. So for the nature of the image means whether the image is virtual or the erect. So this image is virtual because you know the rays are not actually meeting, and erect you can see the object, the direction of the object is this and direction of the object is same, meaning both the cases. Okay. For virtual image there is always the erect image. Talking about the size of the image, you can say that the size of the image is larger than the object. Talking about the position of the image, you can see that is behind the object. This is the object and this is the image. So this is your revision. Okay, all of you.
Yes, sir.
And those who are new in this class, like Manha and Martin, are you getting my voice?
Yeah, I'm here. Okay.
Okay. And till here, if you have any doubt, then please ask me. Now I am
No, sir.
moving forward. I am moving forward. Okay. So now we will place the object. First, what we have done, we have placed the object between the optical center and focus. Now we will place the object at focus. Okay. Now we will place the object at focus. So second case I am taking. This is the convex lens I have, and we all know what is principal axis and full optical center. So this is the lens we have, and this is the focus. Suppose f dash. F dash is the second focus, and now I am placing the object at this focus. This is the object. Suppose this is the object I have placed in front of the convex lens. This is the convex lens, this is the principal axis, and this is the optical center you have. And we have to make the ray diagram. And why we make the ray diagram? Ray diagram gives the idea how and where the image will form. Okay. So for making the image, what we will do? We will please remember one point. For the formation of the image, there is a requirement of two rays from the object. At least two rays. Okay, at least two rays. So first ray is like this. First ray is like this, which is parallel to this principal axis. And I have told you, whenever a ray of light, which is parallel to principal axis will pass from the focus, will pass from the first focus. In case of lens, this ray of light will go like this. Okay. And this is the focus. First focus, you can say, because in lens we have two focuses. Okay. This is the object at focus. And second ray I am taking like this. Like this is the second ray. And so you can see that second ray from the object is like this, and it is passing from the optical center. So just I have told you, if a ray is passing from the optical center, then it will go straight. So this ray will go straight. And in actual, these rays will meet at infinite. Okay, these rays, and image is formed where the rays are meet after refraction. So after refraction, or you can say after passing from this lens, these rays are just parallel. Okay, these are parallel rays. You will get parallel rays. And where the parallel rays will meet? Can anyone tell me? Where the parallel rays will meet? Martin?
Yes, sir.
Parallel rays, where the parallel rays will meet? Do you have idea? Sarah, Arshia, and Hamna, and
Sir, they won't meet.
okay. And what is Manha? What do you say? Do you have any idea where the parallel rays will meet? Okay, fine, no problem. And just if you have a parallel rays, then always you will say that the parallel rays will meet at a very larger distance from us. Okay. At infinite, the parallel rays will meet. Infinite, you can imagine infinite like, suppose you are here, suppose I am here in this room, and sun is far from us. Okay, so the distance between me and that sun, you can say a infinite distance. Infinite distance is very large distance. Okay, so parallel rays will meet at infinite. So this point you have to remember. And you can say that the point where the rays will meet, will be the point where the image will form. So image will be formed at infinite because the rays are meeting at infinite. Okay. Okay. So this was the object. So I am supposing this object as AB object. AB is the object I have placed in front of convex lens. This is convex lens. And this line which is perpendicular to the surface of this lens or passing from the optical center is the principal axis. Okay, this line is the principal axis. And this point O is the optical center. AB is the object and this O is the optical center. These rays will meet at infinite, and if you will talk about what is the nature, position and the size of the image, nature, position and size of the image, if you will talk about, so for image, number first, if you are talking about the nature of the image, nature means always we see whether the image is real, whether the image, there are two types of images, real image and virtual images. The images that you are getting this time, the image of me on your screen is a real image. Okay, there are two types of images. The images are real and virtual. Real images are those images which can be obtained on a screen. So you are getting my image on a screen, that it means that this image is real. Okay, and the image that you will not get on the screen are virtual image, like the image that is formed by the plane mirror. Plane mirror is a mirror that you use, okay, for seeing the condition of yours. Okay, so talking about the nature of the image, so nature of the image as the images as the rays are meeting in actual, so if the rays are meeting in actual, then image always you will say the image will be real image. And if the image is real, then you will say this will be inverted also. Inverted means if your object is like this, then your image will be like this. Inverted means ulti image. Okay, in Hindi we will say real image, and this will be also inverted. Now talking about the size, of the image, as you can see your object is small, but your image will be this time is highly magnified. Your image this time will be highly magnified. Okay, so talking about the size, you will say highly magnified. Highly magnified means very large, very larger than object. Okay, than object. Now the third point or the last point, that for describing the image, there is a requirement of position of the image. Okay, so what about the position? Can anyone tell me what will
Okay.
be the position? Very good, very good. At infinite, the image will form because the rays are meeting at infinite. So the image will form at infinite. Very simple. And what is infinite? Infinite is a very far distance from us. Like sun is very far from us. So that distance you can consider as an infinite distance. Very far distance. So this is the case when I have placed the object at F. At focus, I have placed So this type of ray diagram I will get, and you will also get in your exam that draw the ray diagram when the object is at the focus in front of convex lens. So what you will do? At least two rays you will require. Okay, first ray you will draw first ray like this, means parallel to the principal axis. And when you will follow the laws of refraction, then you will get your image correctly. And you have to write at least these three things: nature, size, and the position. So now you can copy this, all of you.
We're done.
Or just write if those who have not completed. I am saying it again and again. If you have any doubt, then please you can ask me. Abdullah, are you writing?
Yes, sir.
Okay, good. Arshia, are you writing?
Completed, sir.
Hamna
Yes, sir, completed.
and Manha.
Completed, sir.
Sarah, you have already completed. And Martin, what about you?
Yeah, I'm doing so.
Doing okay. Do this. So for the image, you will see three things. First, the nature. Nature means whether the image is real or inverted or virtual or erect. And second thing, you will see the size of the image. You will compare the size of the image with respect to the object. The image either can be bigger than the object, either can be smaller than the object, either the image will be same size as the object. Or about the position means the location of the image with respect to the lens you have or with respect to the object you have. Okay, so these things you have to check out for the image formation. Martin, when completed, you can ask me to move.
Yes, sir, done.
Okay, very good. So now what I am doing, I have told you first I have placed the object here between optical center and this focus. Optical center and this focus, this is the object, and we get the image. And after that, I have placed the object at focus. Now I will place the object between this f dash, and 2f dash in front of the lens. So what we are actually doing, we are just placing the object at different position in front of the convex lens, and we are seeing the nature, position, and the size of the image. So third thing, this is the second thing, and this is the third. When you will place the object between f dash and 2f dash, f dash and 2f dash. What is f dash and 2f dash? This is the convex lens, this is the principal axis, and this is the optical center. This is the optical center, and this time what we will do, we will just place the object in front of the lens at a distance between f and 2f, and this is suppose f dash, and here at an equal distance there will be 2f dash. You can see the distance of f dash and 2f dash. This f dash is at a distance of f, and this f dash is again at a distance of f from this. Okay, so you should know what is f dash, and f dash 2f dash is just the twice of focal length. Okay. So now we are placing the object here. This is our object this time, and we will see where the image will form. So again, there is a requirement of two images. So first will be like this and will pass from the focus, and another image again will be like this, and again this will pass from the focus. Okay, just wait. This will be passed like this. Okay, and second ray will be like this, and both these rays will meet at some point. These rays will meet here, somewhere here. Okay, so what we have done, first ray is like this, and this first ray is parallel to principal axis. This first ray is parallel to principal axis from this object, and this is parallel to principal axis, so it will pass from the focus. Okay, another ray is passing from the optical center. This ray is from the object is passing from the optical center, will pass straight, and both these rays will meet here at this point. So somewhere here these rays will meet, and we will get our image. Okay, so we will get our image like this. This is our image. Okay, this is our image, and this is our object. And object is in between f dash and 2f dash. This is f dash and this is 2f dash. This is 2f dash. Now can anyone tell me what is the nature, position and the size of the image? And I am telling you, here is 2f, here is 2f, and what is f and 2f? This distance is a small f, and again this distance is a small f, and same is the case here. Okay, so talking about the nature of the image, can anyone tell me what will be the nature of the image? Anyone?
Highly diminished.
Not. I am talking. Not talking about the size. That is the size you are telling.
Learnivio.
Huh? Virtual or real? The image will be virtual. Anyone can
Real.
tell. Why real? You can just
Upside down.
try. Okay, why real? Because these rays are actually meeting at a point. Na? After refraction, both the rays are actually meeting at this point. Okay, so nature, you will say the nature of the image will be real and inverted. Inverted, if the image is real, 1 minute. Real and inverted. If the image is real, then always it will be inverted. And one thing more I want to tell you, if you don't want to find if the image is real, then it also inverted. You can see the ray diagram. Okay, ray diagram, you can see the direction of the object, means direction of the arrow of object is in this direction, but the direction of the arrow of image in the downward direction. This thing is the real image. Okay, now talking about the size, you can check here, the object is this, the size of the object or the length of the object is this, and the length of the image is this. So you can guess the image will be larger than the object. When talking about the size, then you can say larger than the object. Clearly it is showing that this is your object and this is your image. The size of the image is greater than your object. And talking about the position, you will say the image will be formed behind 2f. Okay, this is 2f and this is the position of image. So you will say beyond 2f. Beyond 2f. Okay, note it down, all of you. And if you want anything, if you want to ask anything, then please you can ask me.
Done, sir.
Okay. Guys, are you writing with me or just you are understanding the things I am telling? Okay, no problem.
Both.
Done? All of you done? Arshia, Hamna, Manha, Martin,
Yes, sir.
Sara,
Yeah.
Abdullah. If anyone left, then you can tell me, sir. Don't scroll down. I want to write. Okay? Simply you can say that. There is no problem. So means this is the case of when you will place the object between this f dash and 2f dash, and all things are clear from this ray diagram. This is the ray diagram. The examiner can ask you the question, draw the ray diagram when the object is in between f dash and 2f dash. Taking the
Sure.
fourth case. Yeah.
So in the chapter human eye, it's one said like myopia. For that we
Mhm.
have to use concave, convex and concave mirror, right? So
Yeah,
but
yeah.
you said,
Huh?
but you said like in our eye we use lens, but we are like
No,
same in myopia and all, right?
no. I was just saying these are the lenses. I have not saying that these are whether these are convex and concave lens. Both types of lens are used for the different purpose. Okay, for myopia there are the lenses used differently, and for that hypermetropia the lenses are used differently. I am having hypermetropia. Okay, means I am having a long sightness. Okay, so so here are the convex lens used. Okay,
Yes, sir.
so Sarah, your test will be conducted, means have already conducted or it is left test of your school.
Yeah, it will be on 3rd October.
Okay. So Sarah, are you getting this? What I am teaching right now?
Yes, sir.
And all of you, if you have any problem, if you have any doubt, then please you can ask me. So now what we will do? We have just placed the object between this f dash and 2f dash. We have placed the object here. Actually, what we are doing, we are moving in this direction, taking the object with us. Now I am placing the earlier the object here was here. Now I am placing the object at 2f dash. Now I am placing the object at 2f dash. Fourth case. This is the convex lens. Again, I have taken the convex lens. Again, this is the principal axis. And again, this is the axis of the lens. And this point is the optical center. Okay. Now, we will place the object. We will place the object at 2f. So I am supposing this as f dash. This is as 2f dash. Okay. Our object, we have placed the object here now, and we will see how the image will form. We will see how the image will form. So there is a requirement of two rays from the object. First ray is like this, parallel to the principal axis, and another ray will be like this. Another ray will be like this. Okay. So you will get the image like this. Just wait, I will explain. So the image you will get will be like this. This is the image that you will get. Okay. And here the image you will get at again 2f, and this is f. So what you have done, you have the object placed at 2f dash. There is a requirement of two rays. First ray is parallel to the principal axis. So first ray from the object is like this, parallel to the principal axis, and after the refraction, it will pass from the focus. We all know. And second ray is like that. It is passing from the optical center. So if a ray is passing from the optical center, then what will happen? It will not change its path. It will go straight, and both the rays are meeting at this point. And this is the image you will get. This is the image you will get. This is your object earlier. This is your object, and you have placed this time the object at 2f dash. And what is the 2f dash? 2f dash is a distance of 2f. Okay. 2f dash is a distance of 2f, because distance between this optical center and f dash is f, and this distance is also f. When you will add, you will get this 2f dash, and there is no requirement of it. So finally, we have got this image. Finally, we have got this image. Now, can anyone tell me what is the nature of the image? Now I will ask. 8 students are there. Manha, can you tell me the nature of the image? Means I want to ask you that whether the image will be real or image will be virtual.
Will be virtual, sir.
Okay, no problem. And Arshia, what do you say?
Real.
Okay, and Hamna
Sir, real.
and Martin, Sarah, Martin
Real, sir. Real.
and Sarah
Real.
and Abdullah. Okay, no problem. So I have told you, all of you, that if the rays are meeting actual, okay, because Manha has not given the correct answer because she is new in this class. Okay, that is why he have not completed the previous part. Okay, so no problem. With the time you will get. So the image will be real. Why? Because these rays are meeting actually. You can see these rays are meeting actually at this point. So image will be real and also inverted. Okay, real and inverted. And talking about the size. So remember, in this case, whenever you will place the object at 2f, the size of the object and the image will be same. Okay, size of object and the image is same. This point you have to remember. Will be same. Talking about the position, this position anyone can tell the position. This is very simple. You can see this image is forming at 2f, so you can write the position of the image, means the image is at 2f, simply. Okay,
Yes.
same size of the object we are getting. So just copy this, all of you, and then we will discuss the case number 5th. This ray diagram is very easy when you will follow it with a certain strategy. Please try to show in the diagram the arrows correctly. Okay. Manha, are you getting what I am teaching?
Yeah, sir. Now I'm getting.
You are getting now?
Yes, sir.
Very good. Yes. Same thing we are doing again and again. We have an object, we have a lens, and we are just changing the position of the object. Okay, and we are getting different images. We are getting different images. This is the thing.
Done, sir.
Okay, good. And this lens is again, I will tell you, this is a convex lens, and this line is the principal axis, and this O is the optical center. Martin, written?
Yeah, written, sir.
Okay, you are writing.
No, I finished.
Sarah
Yes, sir, done.
and Ashia, Hamna. Written, Ashia.
Yes, sir.
Okay, Hamna, have you written? Manha, what about you? You have also written?
Yes, sir.
Okay, good. Okay, moving to the 4th case. Fourth case, you can guess, means earlier I have placed the object here. Now I will place the object beyond this 2f dash. Okay. Now I will place the object beyond this 2f dash. Simple. So you will write here beyond. What is beyond 2f dash? Object is beyond 2f dash. F dash. Okay. Now let's see. We have a lens. Again, we have a concave lens. This is a concave lens, and this line is the principal axis. Okay, and this is the axis of the lens, and this point center point is the optical center. And suppose this is the focus, means f dash, first focus. This is 2f dash. And here now I have placed the object here. This is our object this time. Beyond 2f dash, beyond 2f dash. This is the object we have. Now again we will repeat the same thing. We will have two. There is a requirement of two rays. First ray will be like this, and this ray is parallel to principal axis. This ray is parallel to principal axis, and this ray will pass from the focus. Okay, and second ray will be like this. It will go like this. Second ray will be like this. Okay, second ray will be like this, and this ray will meet like here. This ray will meet. Okay, so this is your image this time. This is your image this time. And what is happening here? Just see, this is our object. This is our object. From this object, a ray which is parallel to the principal axis falls on this length, and after the refraction, we already know it will pass from the focus. Will pass from the focus, and second ray is going towards the optical center, and this ray is also passing from the optical center. This ray is passing from the optical center, and whenever a ray passes from the optical center, it will go straight. When it will go straight, both the rays will meet here, and here is somewhere 2f. Here is somewhere 2f. So you will get this image. Okay, you will get this image. So this is your object, and this time the image is this. Now talking about the nature of the image, we already know both the rays are meeting actually at this point. No? So this image will be real and inverted. Real and inverted. And talking about the size, for size, you can check the height of the object or the height of the image, or dimension of object or dimension of the image. See, the object is greater than the image now. Here the object is greater this time in size. Okay, so you will write smaller than object, or diminished, you will say. Smaller than object, or you can say diminished. Smaller than object is also known as diminished. Talking about the position, you can easily detect the position from this ray diagram. Ray diagram will tell you each and everything about the image. So see here, this time the image will be in the location of the image will be between f and 2f. Okay, so you will write the image will be in between f and 2f. And what is f? F is at a distance of focal length, means small f. And what is 2f? 2f is a distance of 2 of small. F, 2f, both distances are equal. I have already discussed this thing here. Please don't confuse in it. So this is the case, fourth case. Sorry. This is the.
So totally, how many are there?
How many number of cases you are asking?
Yeah.
There are only one case left. When you that case you already know. If I will say I am placing the object at infinite, I am placing the object in infinite, where the image will be formed. Always remember, in case of lens or in case of mirror, focus and the infinite are interrelated. When the object will be at focus, the image will be at infinite. When the object is infinite, the image will be at focus. Okay, so just copy this, all of
Yes,
you.
sir.
Copy this, please. And if
Done,
anyone
sir.
have doubt, then that person can ask. I think someone has left the meeting. Amna has left, not Amna. Okay, no problem. That's fine. So all of you, I want to ask you that, do you have any doubt till here?
No, sir.
Mean,
No, sir.
uh, Manha, if you are not getting that, if you are not getting that things, then you can follow my previous lecture. Okay,
sir. Yeah, sir.
we will provide you the previous lecture, because I can understand that whenever we start a movie or a chapter from the between, or you can say not from the starting, so it is little bit difficult to digest. Okay, so difficult to understand, you can say. So all of you, Martin, written.
Yeah, written, sir.
If anyone left, then he or she can ask me. Otherwise, I am moving to the sixth. This is the case number. This is case number 5. Okay, sorry. This is case number 5. Now we will have a case number 6. In case number 6, this we have a lens, and this lens we have the object. Okay, we have the object at infinite this time. What is the meaning of object as at infinite? Means the object is at very far distance from the very far distance from the focus, or not focus, from the lens. So the object as at infinite. So now we will see what happens when our object will be at infinite. This is very simple case. What is the meaning of infinite? If you want the meaning of nobody knows. The interesting thing is that I also do not know what is infinite. But I can also say many scientists do not know what is infinite. Infinite is a thing that is not defined. Means anything which is not defined is infinite. And if you want that what is infinite, roughly you can say, you can imagine a distance of yours and the sun is an infinite distance. So this time you will have the object. This is the last case. This is the case. Okay, this time the object is at infinite. And always remember that if you are considering infinite, then consider in your mind, then consider sun. In your mind, consider sun is at a very far distance from us, and from the object and infinite, always the rays are parallel rays will come from the object as infinite. So you can say from the sun we will get the parallel rays. Okay, so the rays will be like this. Rays will be like this. First ray will be like this. Okay, and another ray will be like this, and this ray will meet here, somewhere here. This will meet. So the optical center. Okay, fine. So these are the rays from the infinite. So I am writing here rays from object at infinite. For example, you can take the example of sun. I am not saying that this time the object is sun, but I am saying that you can take the example of the sun. Okay. Sun, not only the sun as infinite, there are many other things that are at infinite. Okay, so just for the imagination, you can just think that sun as it at infinite, and these rays are coming from the infinite, and always remember that parallel rays are coming from the infinite. Always parallel rays. Whenever the object is at infinite, the rays will be parallel. So first ray is like this, passing from the optical center. It will pass straight after reflection. Second ray will be
Hello,
like
sir.
this. Yeah.
Can I just come back? I'll take my charger and come.
Okay. I am just leaving the class. This time is over now. What are you saying?
Okay.
Just this is the last case, and we have that. Oh, we have our time is over now. We have 1 hour class. So this is the image you will get. Okay. This is the image you will get. Okay. So now you can and talking about the nature. I'm just leaving the class in 1 or 2 minutes. What will be the nature? Is the nature of the image real or inverted now? Because the rays are actually meeting here. So real and inverted. Real and inverted. And talking about the size, you can imagine sun is very of large size. If you are imagining the rays are coming from the sun, then you will say the image will be highly diminished. Highly diminished. Okay, all of you, means much smaller than object, much smaller than object. And talking about the position, I have already told you, whenever the object is infinite, the image will be at focus. So just please note it down, all of you.
Okay, sir.